Access to share the screen.
Sure. All right. I think the recording started. This is the working group device management meeting on native resources in DRA for December 2nd. Okay. Yes. You're co-host now, Praveen, so you should be able to do
Okay.
whatever you need.
Uh, I hope my screen is visible.
Yes.
I think last time we were kind of discussing more on what is in scope for at least like the first revision of this cap, and I think we made a decision that like most of the node things, I mean, we can focus more on the API part for alpha. I think, I mean, in this meeting, I wanted to start discussion about like how the API would look like, and I have put some like early ideas in the same kept doc that I had shared earlier. Uh, yeah, I think there were a few comments from Sasha earlier today. Like I did not get a chance to like take a look at them, but yeah, we can start from here and see like how we can evolve this like based on feedback. So currently yeah, the main problem we want to solve with this API is like we have two ways to specify the same resource request like through the pod spec and the resource claim, and we need like a way to manage both of them together. So the API changes that I've put in here, like it involves like changes in the device class API and also in the pod API. In the device class API, the main change is like in the device class spec, we need a field to explicitly say if a device class maps to a native resource. This is kind of similar to the extended resource API, but it needs to be much more involved because like there are different possibilities with like how we can model the native resources. So we have this native resources mapping field, and which is array, and basically within that like we specify what is the resource name, what is like the quality quantity of the device. I will get to that, and what is the combination policy. So basically this is what defines like if a DRA is if DRA is used for native resource, how it would work with the existing pod spec. And a couple of examples that I've added here is like override add. There could be like more possibilities like or more configurations for this combination. Uh, it might be clear like with an example. Yeah, John.
I just wanted to note that this is the device class API. So if you think about
Mhm.
it, the device class API allows the per workload choice of how this accounting is done, but
Mhm.
it doesn't require individual end users to make that choice in
Yeah,
detail. I mean, they'll choose
yeah,
it by choosing the device class. So it
yeah.
kind of protects them a little bit from the complexity, but still
Mhm.
allows it to be per workload. And Praveen and I were talking about this yesterday. I think that's the right choice, but like it's just something we all should think about, and whether I think that what you'll see is Praveen's presenting a bunch of things here in the device class, and I have a lingering question about whether there's some other resource API that we're missing that's not device class and not claim, but works on the workload level. But that might be too much complexity. So I just want to put that thought in people's head to think about it as we move forward over the next few weeks.
Yeah, I think that makes sense. I The other reason for putting this combination policy within the device class API is like it also enables like not all DRA drivers need to support all of the policies. For example, like if with CPU, we currently only it only works with override, so we cannot have like the request specified in both the places. So yeah, this lets like the DRA driver implementation decide like what policy would eventually be supported. And I've also like discussed a couple of options. Like one way to represent this is like in the device class like we have now. The other possibilities through the resource claim, which offers like more flexibility, but yeah, comes at a cost of like all the combination policies like having to be implemented in the DRA driver itself. Um, yeah, Sasha.
Yeah, I just wanted to say a couple of things. So first thing is I would like to remind what we last time we agreed to start actually from the use cases, what we want to support and how we are going to use it, and only afterwards go to API. So Praveen, you created the document.
Oh yeah.
I don't know if you shared it or not, but I started to add the different scenarios and different methods how we should be calculating. Second thing about the API itself. My thinking based on use cases is what it should be not per device class, but actually per device, because we want to support the partitionable devices, like representing the same resources in different variants, and we want to support the consumable capacity. And if we think about it, we might have different proportions on how the native resources can be requested. Like,
But per device is a driver. That's the resource slice API, which is written by the driver, and
yes.
so it locks users into one way of doing it. So yeah, so we need more discussion on that.
Let,
Like
let, let me try to
okay,
give you one example. So, in hardware, the cores are organized in the cache clusters, like or clusters which sharing the same cache. This can be represented as a single device. So the user want to say, give me the whole cache cluster. And that means what I need to give like the whole 4 CPU cores subtracted from the node capacity. AMD have similar like tiles, like 8 cores or something on the tile. So this kind of partitionable devices, what can workload request. So vendor declares like how it maps to native resources, and for user it will be just like more simplistic way to request them.
okay, yeah. Well, let's yeah. I think it comes down to let's experiment with a few different APIs and a few and look through the use cases and look what the different YAMLs will look like. Right? What would the slice look like? What would the device class look like? What would the claim look like? What does the user have to know? What does the administrator have to know? What does the device author have to know? And like I think we just have to kind of I think it's debate. Yeah, it's not clear to me.
My point is what I'm trying to hide from the user complexity, so and
Yes,
hide it behind the vendor. So vendor knows
I,
what it announces and
yes,
how it maps to native resources,
I think
and the
that's
user is just like, I want this class, this amount. That's it.
and I think I agree with that. Absolutely, 100% agree with that motivation. We also hide it from the user a little bit by putting a device class because vendors deliver device classes along with their drivers, and there's some more flexibility there, but it's got pros and cons. So yeah, I think it's a healthy debate. I literally don't know the right answer. I mean, I don't have a strong opinion about it yet.
Yeah, the current proposal uses device class. I haven't explored like how we can use or how we can map it to something in device. I'll look into that. Like I'll work with you, Sasha, on that. Regarding use cases, like I think you've put in three use cases. I took a brief look. I haven't gone in detail, but the current API should support like the DRA driver where CPU or memory is represented as like consumable capacity. I've also been looking into how it would map to if we use partitionable devices. Uh, yeah, I think it would also work like if the resource claim is shared across like different containers, and I've also explored like different pods and so on, and I can get to some details about that. Um, so
There's
mhm.
also and I think Praveen commented on this yesterday. There's a around the sharing concept, and Sasha, we wanted your feedback on this.
Yeah.
Is there a case to share across pods? I guess
Yes,
there is, or attack
where
like that.
yeah, there is a case to share between multiple pods, and it also creates additional accounting variants.
But would we consider that a native resource in the same way, or do we consider that? Do we model that as like a separate type of thing? Because that's the ones that are shared between pods. Is that shared memory? Like what is like that's like a you don't just use that as right. It's not just a malloc, right? I mean, like you have to specifically. Well, okay, we can.
There are several scenarios. Like one is shared memory, so like what memory which is available over the fabric, and it's really one instance, and both containers are just utilizing the same region. So we are well, from node we need to subtract capacity of this region is only once. That's one scenario. Second scenario is it can be more demonstrated with CPUs, with partitioning of the system. So, for example, I want to allocate, let's say, like 20 CPUs, and I want several workloads to consume only those CPUs. So I need to, once this claim is prepared, I need to subtract that capacity out of total node capacity. But when I'm starting the pods, I need to make sure what we're fitting into capacity of that claim.
So that becomes kind of like you want to set aside a pool of resources for a set of pods.
Yes.
One of the questions I would have about that is that really different in the native resource case than it is in any other case? And we have discussed, I guess the accounting is different because we need to be able to move the CPUs between like the general pool and the specific pool. It's a little bit like you're saying with the memory. It's almost a conversion when you go from shared memory, when you go from like ordinary memory that's consumed specifically by a container, and then you go to a shared memory that can be only needs to be accounted for once on the node. It's almost like a conversion or an extraction of the big pool of memory, a smaller bit into something that's shareable. And it's kind of similar with the CPU. So you're taking it out of the big pool and putting it into a private pool. Okay, those are interesting cases, and I think we've talked about the idea of reservation API long term, across cluster wide across all types of resources. And so I'm trying to square that with this concept and whether they're the same thing or they're different things. So that's kind of where I'm coming from.
Yeah, I added those cases actually to the doc. Maybe not very well described, but anyway, it's in the doc, so we can talk about details inside the doc comments.
Okay, thank you. Sorry, Praveen.
Yeah, no problem. I can continue with like what we currently have on the dock with some examples. So this like the first case that I've described is like the Slurm use case where we want each CPU to be represented as a specific device. And in this case, like on the device class, how we model that is like we have this native resource section, we have resource name, we have combination policy, which would mean that like whatever is there in the resource claim overrides the pod spec. And in the quantity from field we specify like per instance, where like it just means every device in the resource claim would map to like one CPU. If we decide to model this like differently, say every L3 cache is a device, this would just be like number of CPUs on the L3 cache. The second mode of like modeling the CPU or like the native resource
Hang
is
on, before you go there, can I ask some questions?
Mhm.
Okay, so can we just have a little context? So is this telling us how to interpret this highlighted section here in the device class? Is this
Mhm.
telling us how to interpret the CPU request in the container spec or
No, this
resource?
is telling like in the resource claim, if there is a request for like say six devices, it is telling how many CPUs those six devices map to. Like in this case, it is one because every CPU is enumerated as a device, but that need not be the case always.
Okay, so right in there are two places we specify. We can specify um, there are kind of three places we specify. Well, okay, actually, there's more. There's pod pod level resources. There's
Mhm.
container level resources in the pod spec container spec,
Mhm.
and then in a resource claim, there's an ask for a count and
Mhm.
there's an ask for a consumable capacity. So
Mhm.
what I would like to understand is with this configuration in the device class,
Mhm.
what happens with the values put in each of those locations for any given claim? And
Okay.
how does the change in the values, the configuration of the device class impact the requests in each of those? So like that table would be super useful, I think.
Okay. In
Yeah.
this case, like this specifically maps to the count in the resource claim. The next section I have added about like the consumable capacity thing. But for the count case, like if the resource claim has six, it means that like the DRA plugin would allocate it like six devices. This per instance quantity will tell us like each of those six devices map to how many CPUs on the node. So yeah,
So in
like
Sasha's case of where he's like, I want to be able to allocate four CPUs as a single device because they
mhm,
all share the same
yeah,
L3 cache,
yeah,
the
yeah,
value here would be four.
yeah. So basically, if each device is like say L3 cache 0, L3 cache 1, and so on, and we know that like each L3 cache has 8 CPUs, yeah, you're right. Like this device class would be like quantity from would be per instance eight or four or yeah, however we decide to model the CPU. So that is like the device instance based modeling. Uh, the next thing is the consumable capacity based modeling, where this is an example resource slice that I have. Uh, in this we have like consumable capacity for like CPU, I mean socket 0 CPU 128, memory 64, same on socket 1. How we describe that in the device class is like basically we say resource is memory, we say combination policy is add, like whatever is there in the resource claim adds to whatever is there in the container spec, and we say quantity from. This basically tells the accounting model like when it sees a claim, look for like this as a key and use the value in the claim like specific to this key. Like for memory this maps to the memory capacity, and for CPU this maps to the CPU capacity thing. So this quantity from is mostly for the accounting part on the dynamic resources plugin to specifically say like what in the resource claim corresponds to this native resource type. Uh,
So it would account,
any
it would do accounting so the node resources plugin.
Mhm.
Um, I guess so. We're going to look at the I guess the dynamic resources is going to look at the native resource availability and combine it according to that combination policy,
Yeah,
and then determine whether we can fit on that
yeah.
node or not.
Uh, I can explain a bit more about the accounting part, which I've added like later on in the doc.
Okay.
But
Uh,
that's example exactly what I was talking about, or partitionable devices or not. So
mhm,
that's practically uses the different class definitions just to not,
mhm.
well, instead of partitionable devices concept. I would rather to have like single class with multiple devices exposed, with different variants how I'm exposing it, like either individual cores or grouped cores and so on, but just to have for each variant, for each device, declare what will be the proportion of native resources for each variant.
Yeah, like the proportion part, I'm not still very clear on like how we can say if we request this accelerator also give X% of the node, if I understand correctly what you mean. But in this device class, we can still specify like multiple like resources in the same device class. Like here we have both memory and CPU in the same class.
By proportion, I meant what like device, well, cluster zero means for CPUs, not the percentage.
Yeah, I think let's yeah, I think we're going to need to. I think what we're going to end up doing is having several different possible APIs, and like I said, there's going to be examples of how we would model the different use cases in each of those APIs, and try to understand um, where we're moving the complexity, and like when we move complexity to the driver, that's good for the user, but it's also makes decisions have to be made at driver instantiation time, not at workload creation time. Um, so we have to think about from the use cases, driving from the use cases, whether that what we actually need there. Um, so let's continue with Praveen's current proposal, which is doing it in the device class layer, and then we probably have at least two or three other proposals for for how we might do this.
Okay, so coming to the pod API changes, like in the pod status, we would have this field called like native resource claim status, which would basically tell like for a given pod, what are all of the claims, what are those containers like which are using the claims and the resources. So in this example, like I have two claims like container one and two are using the same claim and three is using a different claim. So this is how the status would look like. So for each claim, we would list like all of the containers, the resources, the combination. We also pass the combination policy. Uh, yeah, like yeah, this should be sufficient for like the resource accounting part, which I'll explain in a bit. So uh, yeah, like on the cube scheduler side, like this is how uh, like the API should come together for resource accounting. We have node resources fit plugin, like which in this case it will look at a device class and identify if a resource is backed by DRA, and it would delegate the responsibility of accounting to the dynamic resources plugin. Uh, and in the filter stage, like basically on the dynamic resources plugin, uh, like we would need to do like an effective calculation for this resource based on the combination policy. So uh, we'll look at the resource claim, we'll look at the quantity, we will also based if the combination policy is add, we look at the pod spec and determine the overall resource request, including both the things. And node it will use the same node info cache that we currently use in the node resources plugin to evaluate like if the node has enough capacity to satisfy both these things. And based on that, like we pick the node. And in the pre-bind stage, this is where we update the pod status and also the resource claim status. We update the pod status to include the native resource claim status, that like the API that I just described, to basically indicate like all of the resource claim and the capacity. This is then passed to the bind stage. This is where like the scheduler will update it internal like node info cache, and it uses the pod status to calculate like one all of the claims, like all of the resource claim. It'll also do like a dedupe for if there are multiple containers using the same claim, like it'll account for it only once and so on. I've also added a question of like if we need to support cases where like multiple pods can use the same claim, but yeah, we can discuss more on that. But yeah, it would look at two places, like the pod spec and the pod status, and compute like the effective resource that is used by this pod, and update the node info cache. So the node info cache will continue to be like the single place where like we account for all of the resource requests. Like any thoughts on this? I, so yeah, Dominic.
So does it mean that once we have configured the native resource backed by DRA, we will
Mhm.
not effectively use the native resource directly anymore, right?
No, we can still have pods which don't use like resource claims. So that is the reason why like we'll need to update the node info cache based on like both resource claim and standard requests. So if there is a pod without resource claim, like the node resource fit plugin will continue to work the way it does today. It looks at the node info cache, checks the pod spec, and figure out if it's a fit. But only for resources back through DRA, it is that responsibility is delegated to the dynamic resources plugin.
Mm-hmm.
So since it's all in a shared cache shared between the plugins and the node info cache, what you're saying is that when we bind, we update the node info cache based upon the DRA resources used. And so we update the underlying node info cache for CPU memory, whatever it is, so that
Yeah.
that then the node resources plugin continues to work for the next scheduling, if it even
Yeah.
use DRA.
Yeah. Yeah.
I suspect that it should be earlier than in binding, because binding is asynchronous and we need to account for those resources in scheduling cycle.
Okay, wherever it's done today is probably the same place to do
Yeah.
it.
Yeah. It will
Yeah,
continue to
that's the
be
detail.
done. Sorry, I missed the last part.
Yeah, that's probably the detail we can work on it.
Yeah, from what I understood, like it happens during binding where we add the pod, and the plan is to update that to also account for like things that we've added in the pod status. So yeah. So that's mostly what I had about the API. Like this should work for multiple containers with the same claim. If we need this to work for multiple pods sharing the same claim, we need more changes on the scheduler framework to know, like, for a given node, what are all the resource claims that are already like accounted for, and if there's a new pod with the same claim, we need to kind of dedupe an existing like resource claim that has already been allocated. But at this time I wasn't sure like if we need to support such use cases. The other possibility is like a pod has a claim but it is not referenced through like any of the containers within the pod. But I think like since on the dynamic resources plugin, we've already allocated the device, we would still need to account for those when we are updating the node info cache. So these are the three like special cases that I could think of. There could be more. Uh, yeah, like for these cases, it should mostly work. Uh, yeah, Marlo?
Just real quick, do we still have a limit to the number of resources we can give to a pod? Is that still 32 there? Because that will
Yeah, I think
still be a
that is
problem.
still there. Like, yeah, that is the
Yeah.
other two things that I've listed here. I haven't like expanded on that in the kept. I think those are like different discussion points. But yeah, we still do have like a limit on number of devices per slice, and also the number of device requests per claim. Yeah.
Yeah, the first one we can hack around, the second one can't.
So
Yeah.
the discussion, okay, that's devices per claim as opposed to, there's another limit, which is the claims or the reserved for in the claim. You don't care about that in this context. But what you care about is the number of devices per claim.
Yep.
Yeah. And what sort of number do you need there?
Well, if we use case is one device per CPU, so for today volts, we need to account up to 1024 at least.
That's not all.
Plus the any other items, so GPUs or
Yeah.
NICs or whatever.
But in reality, the current Linux kernel is 8K CPUs. What is current limit?
Yeah. I wonder if there's a step C here, which is some sort of grouping mechanism or indirection. Option C that we need to introduce, because no matter what number we put in there, I mean, one, we have etcd size limits. We have, although devices are just names here, they're just single strings, right? They're not. Okay.
Well, John, that's the reason why I'm so much arguing about the partitionable devices and consumable capacity, because it can allow us to model based on the topology. So you don't need to request per one by one. You can say like, give me everything in that topology zone.
Right. You could use partitionable where you have them available one by one, but you also have them available in blocks of, however big you want. And then rather than the single device being the one by one, it's just like, I want all of those 128 in one go. That would be a big mechanism, I guess. Yeah. So there's option C, which is use partitionable to group individual CPUs. Because Marlo, you're not going to be like, basically it allows you to define levels of granularity. You could be like, I can have up to 32 individual ones, or I can create a group of 32 and add that as one, whatever. That might
Well, a group of 32, where that group is these particular enumerated cores.
right. If you even if you group them into groups of 8 and 16 and 32, then you could use those to compose any set of CPUs you wanted.
Yeah, I guess we could have an agent running there that did the
You wouldn't
actual
even need an
enumeration.
agent. You would just need to understand in your algorithm that selects the cores how to construct the set of cores you want, how to map that into a minimal set, right? So like
Mhm.
okay, if I've got 1,024 cores, and then I list them all individually, but then I also list all the groups of or I list combinations of 4 and 8 and 16 and 32 and 64. I get a lot of devices, but like if you're doing 500, you're gonna be able to take some contiguous blocks of 128 and combine them into those 500, and then add the few extras on. You see what I'm saying?
Yeah, I'm just thinking how interesting some of the architectures are getting.
I mean, if you want to do something like 1 1 1, right? Like if you want to do some like
I can completely see someone doing that. I don't know.
weird thing, but we might be limited. But we're talking really obscure cases, it would seem.
I hope so.
Yeah, that's why we need use case and sort of not just this is a use case, but this is a use case and it's super common, or this is a weird edge case, and if we can't cover it, we can't cover it. Like we don't have to do everything in the world. Like there might be just things where somebody has to handcraft it,
Yeah. Okay.
So that's mostly what I had on the API side. Like I can expand more or explore more on how like other possibilities might look like, including like representing using the device API. Yeah, we can have a follow-up discussion around that.
Okay, and then you have a section here on partitionable devices. Did you
Yeah,
start?
this is currently like mostly exploratory. Like I was trying to figure out like how the existing API like with the device class in here, like how it could map to devices that if they are represented through like partitionable devices. So this is what I could like come up with, but it might have some gaps. Like basically, if we have shared counters for each socket, and within that we enumerate like different types of like I mean basically NUMA, L3 cache, CPU, and so on. uh yeah, like in the device class API, it should still mostly work if we use the consumed capacity thing and map. So one requirement is like in the resource slice with partitionable devices, like each device should specify this capacity field, which I believe is currently like optional. So this capacity field is like different for different partitions. Like if for L3, this is like this maps to 8. For the if we want the entire NUMA node, this maps to 32. So
Yeah,
basically, for each partition, we have a different capacity field,
yeah.
and in the device
That's
class,
normal with that's how MIG would work and everything,
yeah,
right?
yeah.
Now, what we don't have,
Mhm.
as far as I know,
Yeah, what we don't have is like with consumable
yeah,
capacity in so this is a sample like resource claim with consumable capacity. The easy way to account for resources is like in the resource claim status, we have consumed capacity, which directly tells us like for this device what is the amount of CPUs that we ended up allocating. But this is something that is missing for like partitionable devices. We don't have anything in the resource claim status which says like all we have is we allocated this L3 cache.
Right.
We do not have anything to explicitly say that this L3 cache has these many CPUs.
Right.
But I think like this is something. I mean, I don't know if it's a possibility to expand on the device or like the resource claim status API to include more information. But a relatively easy way to get around this is in the dynamic resources plugin. We need to do like a two-level lookup. Like one, we see the resource claim, see what is allocated. We need to go back and look at the resource slice to figure out like in this partition what is the capacity, and then add that correctly in the pod status. So yeah, there is a
Okay,
workaround
there's
right
a
now.
couple of thoughts there. One is, so the way partitionable device is implemented today, it just records the device name, and it's in the resource slice what counters and counter sets and all of that corresponds to, and which is okay, but like a lot of the things we have, like we try and copy values on an as was basis, so that if there's a change to the resource slice, existing information, we have any information, we don't need to look up any information there. So if this is information we need, like to do accounting or allocation, like we probably should have it in there. The thing is that the pools it's coming from, we're not going to copy those over. So it gets a little bit iffy. So that's one thing. The other thing is that there's a distinction between the capacities, which are user facing and may or may not be consumable, and the counter sets. That's why they have different names. The counter sets are not user facing, they're just driver facing. And I'm very hesitant to copy counter set consumption into the pod status because it's really a driver detail that the user shouldn't know anything about. On the other hand, like if we can configure a partitionable device with consumable capacity, I assume that the way that works today is if you allocate any share of that device, all the counter sets get consumed as if a whole device was allocated, and then the sharing shifts to the consumable capacity shares. So those would get stored in the status. So I don't know. Those are my thoughts. Like I'm hesitant to put counter set consumption into the pod status rather, and I'm not sure we need it because
Yeah, like I think the pod status can continue to hold just like the raw quantity, and all of the heavy lifting can be done within the dynamic resources plugin itself because it has all of the information. Me and Morton were also discussing about this. Like what is not currently unclear is like if we need some API changes to expose this capacity, or like if we are okay with like handling all of this like within the dynamic resources plugin itself. Like basically it knows about device class, it knows about resource slice, it knows about claim, just combine all of these information together and map it to one quantity information that gets passed to the pod status and
I'm not
is
clear
used
why
for
we need
counting.
something in the pod status, because in the case of partitionable, the capacity there is a fixed value that doesn't change, and it's determined by the partitioning done by the driver. And in the case of consumable capacity, we already have the capacity in there. So what is the case you think you might need to record it now, and why?
Even with partitionable devices, like for uh, during the bind stage, when we want to account for resources, we still need something like this in the pod status, which
Oh,
says like, uh, I allocated this device, this uses these
got
native
it.
resources,
Yes.
and with this quantity. We don't
Because you need
need
to
like
take it from
detailed
the node
information.
info cache from
Yeah,
the
yeah,
general
yeah,
pool, not okay. Okay,
yeah,
so you need it recorded there to be able to do that.
yeah.
I see.
But we don't need the details of like what is the counter set or like what is the shared counter and stuff. We
Right.
just need raw quantity of how much memory was used by this resource claim. That's pretty much all we need.
Okay.
Because the node info cache is just a scalar. It just needs to know how much is available, how much is consumed, and if we can like push that through the pod status, that should be sufficient. Sasha?
Yeah, I wanted to also say something similar. So what we really need is like when we are processing the pod which contains the claims, we need to calculate just sum of what is the native resources will be needed by all of those claims and put it in the
Yeah.
pod status. So when the normal scheduling happening, it just knows what this pod consumes that amount of native resources and not looking into the details. That's it.
Okay. So this gets to your proposal from a couple of months ago, Sasha, of like, can we just tag individual devices with the native resources consumed? And then what we would do is if we did that, then that would move out of the device class and into the device, is what you're suggesting. And then during this process, at least, what we would be able to calculate that directly out of that, and just record it here.
Yeah, and that's exactly what I'm saying. Yes.
Okay.
So the device entity declares like how much of the native resources of different types it consumes. That's it. So as soon as we calculate well, as soon as we start using that device, we calculate how much of
Okay. So for
native
your use
resources.
case, let me just go somewhere. So for your use case where you said you want to be able to allocate these 8 CPUs and then you want to share them amongst a bunch of pods, could you use each of those containers in each of those pods? If they used consumable capacity from the device, the first pod that came along would select the device, that would allocate the device, and it would need to record at that time that from a node info cache point of view, that entire set of 8 CPUs is consumed because this device has been allocated. But then your next pod that comes along, but you're only giving one share of, say, one CPU to that pod. And then another one comes along and asks for a share of that device. And we use consumable capacity there. Our node statuses would get really confused because the first pod would record the 8 CPUs, and the second pod would then, I guess, record 0, which is
I see.
age.
I see where you're going. It's tricky. That's why I was saying like let's put it in the writing and then we can think about it.
Okay. I feel like the pod might not be the right. This is a common problem we have across shared across pods, is that the first pod gets a sort of special privilege, and
it's not only about this use case when the one claim is used out of several pods. It also will be applicable for, let's say, like shared memory. So like it's allocated once, but when it's consumed by multiple.
right. And when do we deallocate it? We deallocate it when it's not used. But today, what we do is when the reserve for goes to 0, right? When nobody's using it anymore, we deallocate it.
Yeah. Yes.
But that works for us for now, but it doesn't work for this accounting in the pod status, right? Because we don't know how to, like, which of those. If you deleted the first pod, you have to somehow transfer it to the other status, and it gets really, or you have to put it in every pod, and then you just have to deduplicate it, which I think is what Praveen is proposing.
Yeah, like
What
currently. Go ahead, Sasha.
what we can try to do, and I don't know if it's feasible or not, is actually scheduler knows which claims are ready to be consumed on the node. So we can extend the claim status, which says this
Yeah.
claim consumed this amount of native resources out of the node.
Yeah, we might put it in claim status instead. Yeah.
In that scenario, for this like shared use cases, we are not accounting it to the pod per se, but we are counting to the claim.
That makes more sense, like from a modeling point of view.
Yeah, but it means like we will have it in two places. I mean, like for simple scenarios, we need to have it on pod level. For more complex scenarios, we also need to have it on the claim stack.
Well, we kind of do this with
Well, you do it with consumable capacity.
Well, no, yeah, yes, but I was going to say we're stuffing things right now in the pod status that maybe should be in the claim status. So, like with pod resource health, we if multiple pods use a claim that represents one underlying device, and that device returns an unhealthy status of some sort, then that gets automatically reflected in all the pod statuses, and that was an intentional choice. I mean, this is an alpha feature too, but that was an intentional choice because customers want to look at them. They don't have to go like, oh, I go look at the pod status and it doesn't show any problems, but I have to go like dig into like the resource claim status to see any problems. But for this accounting stuff, that's not really for users, but is really more for our scheduler. Maybe it makes sense to stick them in the resource claim status for consumable capacity too. Like maybe we put it in the wrong place. If that's where we put it now in the pod status. I think that's still alpha. We could probably change it if we need to. Something to think about.
Well, anyway, we are not going to solve it today for now. we need to start writing all of this.
Yeah, let's start. I mean, Praveen started writing all of it. Let's continue, and it's a lot, right? There's a lot of decisions to make here, and like let's just try to make some incremental progress in 136.
Yeah, that device limit we need to sort out, John.
Yeah.
Yeah.
Do we have an open issue in KK or something on that?
Not that I know of, but I can go look for it.
Okay, we should make sure that gets created.
Yep.
And tagged with the working group so that it's on our board. Okay, well, how much time? We have 5 minutes left. Praveen, did you have any? You've covered.
Yeah, I think this is everything I wanted to discuss today. I have taken a few follow-up items. I can try and explore that a bit more, and we can talk about it the next time.
Okay.
So yeah.
So I know there's like 20 some people on here, and this has been a super in-depth conversation that probably is not of interest to everybody on the call, but this is probably what these calls are going to be like. So just FYI, like this isn't the regular working group call. This is a very specific tactical call about a specific problem we're trying to solve. So you are all welcome, but just so you know, it may be not all of interest to everybody. And
don't be shy to speak up.
Yes, exactly. Yeah, it's me and Praveen and Sasha doing most of the talking, but please jump in. And Praveen's been pretty thorough here with his write-up, so please take a look. And I think the place people who aren't as in-depth involved in the details maybe still could offer some real help would be looking at the use case document as well. And in particular, I haven't seen it yet, so maybe this is already in there, but I'd like to understand the use cases around combinations of devices. So I know one or two from us internally here, like around CPU and NIC alignment, for example. But I know that the HPC use cases sometimes have some very specific things. Marlo, probably letting you list individual CPUs means Kubernetes doesn't have to necessarily ingest all the complexity of all those HPC use cases, which is good, right? We can leave those in Slurm or wherever, but still it would be good to at least understand at a high level what some of those are so that we can make sure that we don't, we don't need to solve them all, but we need to understand them so that the model can let you solve them, I guess. That's one way.
Yeah, that won't just be for HPC. That'll also be for telco because they need that sort of granularity.
Okay.
Not really.
Okay. I'm not getting involved in that. Okay. So thank you all. And I guess if there's no other comments, we can wrap up with 2 minutes left.
Yeah. Thanks, everyone. Open to feedback on the doc as well. I've added both the links in the meeting notes.
Okay. Thank you.
Thanks. Bye.